Hello, guys. Welcome to Romita Solutions and welcome to your grade 10 electric circuits. Today, we are looking at an example. I'm sorry, I didn't even note when you guys wrote this exam paper, but it's okay. The key thing is to basically do the questions. So let's see. I will try to write on top of this question. If not, I'm going to go to the next page. So this question says, define the term potential difference. What is it? Potential difference. Maybe let me use red color. Should I? Let me see. Green is perfect or red? Nah, let me use red. So we know that potential difference is basically work done in moving a unit charge between 2 points, or work done per unit charge, whichever you prefer, or even energy transferred per coulomb of charge. But I like this, energy transferred per coulomb of charge. All right, energy transferred per coulomb of charge. All right, energy transferred per coulomb of charge. All right, perfect. So 2 marks already. Remember, you should try to do this question in 13 minutes. Okay, but I will take longer because I'm also explaining. All right, now we have, they say, calculate the in the electric circuits given below, the ammeter and connecting wires have negligible resistance. That's an important point. And the battery have no internal resistance. Another important point, you will understand this no internal resistance when you're in grade 12. Now, calculate the resistance of the circuit. Something that you need to know is, remember I said when you get to your circuits, through the direction of current, it goes in this way. So here is it. As it gets here, current gets divided. So what is our total resistance? 1 over Rp is equal to 1 over R1 plus 1 over R2. What is this? This is 1 over 6 plus 1 over 12. I believe on your calculator this returns, let me see, it returns 2 plus 1 is 3. 3 over 12. 3 over 12 is 1 over 4. Please confirm. So 1 over Rp is 1 over 3. Yeah. No. 1 over 4. Let's confirm. 1 over 6 plus 1 over 12. Where's my calculator? 1 over 6 plus 1 over 12. It's 1 over 4. Therefore, this means Rp is 4 ohms. Okay. This means Rp is 4 ohms. Okay. So, that means we are good to go. Now, we have 3 marks plus that 2, that's 5 marks in the back. Calculate the amount of charge that flows through the 6 ohm resistor in 4 seconds if the reading on the ammeter is 0.9 A. Calculate the amount of charge. Guys, the amount of charge flowing through here. For this, I will go to the next thingy. I'll go to the next page. So what we know, we do not know what we know. They say in the 6 ohm if the reading on the ammeter. So this is the ammeter. That's what we know. So we need 2 options. I'm going to show you 2 ways of doing this. But first, let me show you the 11.2.2. 11.2.2. I like saying, because this is a parallel connection, what I know, I said to you, V parallel will be equal to V, let me see, we're looking for the current flowing in the 6 ohm resistor. All right, the current flowing in the 6 ohm, oh no, we're looking for the charge. So we're going to start by looking at the current flowing in the 6 ohm resistor. So this is the 6 ohm, but we have the total current because the reading on the ammeter, which is the total current, is 0.9. Okay, cool. So it is equal to V of that 6 ohm. This is option 1. Okay. So we know, guys, we know that R is equal to V over I. This therefore implies V is equal to IR. Okay. Now, therefore, I will say this means I total or IP, in this case, let me say IP and RP is equal to I in the 6 ohm resistor and resistance of the 6 ohm resistor. Okay. Now, what is this IP? This IP is the same as the current that's here because it's the total current, right? IP is the total current. What is it? It was, it was 0.9. It was 0.9. Now, what is resistance of the parallel combination, RP? We calculated it. I believe it was 4. Here is it. It was 4 ohms. It was 4 ohms. Do we know current in the 6 ohm? We do not know it. Now, what is the resistance? It's 6 ohm. Okay, perfect. Now, let's see. What we have, we have 4 times 0.9, which is 3.6. So 3.6 equals 6I at the 6 ohm. Now, 3.6 divided by 6 is 0.6. Therefore, current of the 6 ohm resistor is 0.6 amperes. You are not done. You didn't answer the question. The question said calculate the amount of charge. And what we know that current is equal to charge over delta T. Right? Now, what is current at this thing, at this resistor? It's 0.6. What is the charge? We do not know. What is the time? The time is 40 seconds. So we will divide by 40. Right? We will divide by 40. Maybe I should also add here. Now, charge. Okay. Now, we will say charge is 0.6 times 40. Let's see. Charge is 0.6 times 40. What is 0.6 times 40? 0.6 times 40 is 6 times 4 is 24. 24, okay, let me see. 6 times 4 is 24. So times 40 is 240. So it'll be 24 because, yeah, it'll be 24. So this is 24 coulomb. On my calculator, 0.6 times 40, it's 24. So your charge is 24 coulombs. Remember the question was saying to us, calculate the amount of charge that flows through the ammeter, right? Calculate the amount of charge that flows through the 6 ohm resistor in 40 seconds if the reading on the ammeter is 0.9 amperes. Okay, if the reading on the ammeter is 0.9 amperes. Okay, perfect. So, option 2, which I don't know if we should really look at, but perhaps let's look at it. Option 2 of solving this. Option 2, I will say R is equal to V over I. Right? R is equal to V over I. What is R that I'm talking about? I'm talking of RP, VP, IP. What is it? It was 4 ohms. What is VP? We do not know, do we? They didn't give us the total potential difference. It's okay. But they have given us, what is this? Total current. So we will say it is equal to 0.9, isn't it? Is it 0.9? Yes, 0.9 amperes. That's the total current. So, therefore, V is equal to 4 times 0.9. So 4 times 9 is, let me see, 9, 18, 36. So this must be 3.6 maybe. 0.9 times 4, 3.6. So, sorry, V sub P. So V sub P is 3.6 volts. All right? So the potential difference of the parallel connection is 3.6 volts. Now we need to know the current. Okay? We need to know the current do we even know the current that's flowing here? In a way, yeah, we know it, right? In a way, yeah, we know it. So we also know the formula. Check this out. We also know the formula. Hold on. We also know the formula. V is equal to W over Q. But we don't have this part. So it'll be really a total waste of time. So what do we need to do? What we need to do now is, okay, let's find the current flowing at resistor A6. So resistor 6 ohms. So resistance of 6 ohms with its Vp, because it's the same current, and current flowing at 6 ohms. All right. And what is this? This was 6 ohms and Vp was 3.6. Current is still unknown, so we can say current is basically 3.6 over 6. What is it? It's 0.6. So this is 0.6 amperes, right? It's 0.6 amperes, right? Therefore, current at the 6 ohm resistor is 0.6 amperes. Can you guys see that? It is 0.6 amperes. But then what else do you know? You need to find charge. Now charge is current over charge over delta T. What is the current? The current flowing is 0.6. What is the charge? We do not know. What was the time? It was 40 seconds. 6 times 4 is 24. 6 times 40 is 240. So this will be 24, like we said. Therefore, Q is, maybe let me do this, times 14. So Q is 24 coulomb. Isn't that what we did earlier? Indeed, it is. It is 24 coulombs. Okay. It is 24 coulombs. And this is how we solve it. Okay. You guys will have to look at this over and over, but whichever method you prefer, it's okay. Now, let's check this out. How does the potential difference across the 6 ohm resistor and potential difference across the 12 ohm resistor compare? I like this one. Guys, hear me out. How does the potential difference across the 6 ohm resistor and the potential difference across the 12 ohm resistor compare? Right? Only higher across 6 ohm or lower across 6 ohm or the same as? Guys, these, hear me out. These, are you listening? These are resistors connected in parallel. Now, since they are resistors connected in parallel, our answer is simply the same as, because resistors connected in parallel have the same potential difference. Okay. Resistors connected in parallel have the same potential difference. Now, a low resistance copper wire is now connected between points P and Q. Points P and Q. Oh, this is interesting. A low resistance copper wire is now connected between points P and Q. Okay, points P and Q. So it means the current that's flowing here basically will be high. So we shouldn't necessarily be worried about it. Right? We shouldn't necessarily be worried about it. There is no longer a 12 ohm resistor. Right? There is no longer a 12 ohms resistor. Right? Now, since there is no longer a 12 ohm resistor, this means current is basically not affected. Right? This means current is no longer affected, but there's no resistance whatsoever. So current is not affected. Right? So, with that being said, they ask you now, will the reading on the ammeter increase, become 0, or decrease? If really this line, there is no resistance whatsoever. Right? If there is no resistance whatsoever on this line, we shouldn't be worried about it. So what does it mean? What it means is that, oh, now the total current or the current RP increases. right? From 4 ohms. Since this one is out, it will now only focus on this one, which will be 6 ohms, right? It will now be 6 ohms. And if it's 6 ohms, look at it, 6 ohms is greater than 4 ohms. What does it mean? It means total resistance will also increase because the resistance of the parallel connection increases. Now, how is this affecting the ammeter? It's affecting the ammeter because how will it affect the ammeter? If the resistance increases, the ammeter will decrease, right? If the resistance increases, the ammeter reading will decrease. So our answer here is decrease. All right. So what is the reason? The reason is this. Give a reason for your answer. Total resistance will increase. Total resistance will increase, and then R is indirectly proportional to current. Therefore, current will decrease. Therefore, current, please write this. Therefore, current will decrease. Okay. When RT increases, current will decrease. Okay. And this is how you answer these questions. Okay, guys. All right. So 13 marks for you. Interesting. So, bye-bye.